Now let's talk about the more complex types. So arrays and objects here. And let's start with arrays. If I have my hobbies, that might be an array of strings. Hence, this type assignment is wrong. This allows me to store a single string in hobbies, but I want to have an array of strings. To tell TypeScript that I want an array of strings in there, we can instead assign this type, string with square brackets thereafter. This tells TypeScript that we want to have an array of strings in hobbies. And of course, we could have the same with an array of numbers, an array of booleans, whatever. But here I want to have an array of strings, and that allows me to store an array of strings in there, like this. Now this is possible. If I would add a number in addition to the strings, I again would get an error, because that's not a string, and I'm making it very clear that only an array of strings may be stored in hobbies. So that's how we can set up array types. Now we also can set types for entire objects. Let's say I have a person variable, and in there I don't want to store a name or an age, but an object. I want to be able to store something like this, an object with a name and an age. Something like that. That should be stored in person. Now, of course, this works like that because TypeScript out of the box without configuration is quite forgiving, and it by default allows me to store any value in a variable. It has a special any type for this, which we can see if we hover over person. The default type assumed is the any type, which we can also explicitly set like this, which simply tells TypeScript, I don't want to tell you anything about the types of values stored in this variable. Anything is allowed. And that, of course, is a fallback type, which you typically should not use, because that kind of defeats the entire purpose of using TypeScript in the first place. With the any type, you're basically back to standard JavaScript. So it's the default, but of course, it's not what I want to keep here. Instead, I want to make it very clear which kind of object can be stored in person. I want to allow this object, for example, but storing another object with a different structure, where I have, let's say, just a boolean in there, that's something I don't want to allow. And for this, we can again add a type assignment, but now we want to add an object type, a type defining an object. And for this, we then add curly braces, just as we do it when we create an object. But please note that this is not on the right side of an equal sign here. So we're not creating an object here. Instead here, it's in the place where we set a type for a variable on the right side of this colon after the variable name. And therefore this here is actually a type assignment. And hence here we're not creating an object, but instead we're using a TypeScript feature here, which is the object type definition. So we're defining the type for an object. We're defining the structure of an object. And here we can then, for example, say that person should store objects that have a name field where the value of that name field is a string, and which have an age field where the value is number. So where the value is of type number, I should say. And with that, we're telling TypeScript that only objects that have this kind of type should be storable in that variable. That's why I can store this object here, because that object down there has exactly the structure I'm defining here. It has a name field, which has a string as a value, and the age field, which has a number as a value. On the other hand, this object down here is not storable, and hence I'm getting an error here because it is having the wrong type. This object's type would be that it has an isEmployee field, which stores a value of type boolean, which does not match this type description here. So I'll comment this out. And that's how we can define array types and object types. Of course, we could also combine these two. If I wanted to have an array full of people, so full of people that have this type signature here, then I could set the type of people here to this object type. So I'm repeating this, but as an array by adding square brackets thereafter. Now I'm saying in people, I don't want to store a single object of that structure, but an array of such objects. And that's how we can then already get a bit more advanced by combining different TypeScript features and by combining different types. Now that we learned about those base types, before I'll dive into functions and parameters, I want to talk about type inference. In all those examples which are listed here, I always declared a variable with a type assigned, and then in a second step, I set a value. Now, often in programming, you do that in one step. You create a variable, and you then also immediately assign an initial value. So therefore here, let's talk about type inference. And let me show you what that is. Let's say we have another variable down there, the course variable, and in that course variable, I want to store the name of a course, like React the Complete Guide, like this. Now, if I create this variable like this, and thereafter I try to store a number, for example, the course ID, then you will see that I get an error, because the type number is not assignable to type string. But why am I getting this error? After all, I don't define a type anywhere. Well, here TypeScript used its powerful feature of type inference. By default, TypeScript tries to infer as many types as possible. So it tries to know which types are used where without you explicitly stating those types, which means that you need to write less code. I could also set my type here, as we learned it. That would not be wrong, but it's redundant. Because if you immediately initialize this variable with a type, TypeScript will look at the value type here, so it will see that we stored a string in that variable, and it will then use that value type as an inferred type for this variable. And if you then try to assign a different type thereafter, you'll get an error because of type inference. And it is considered a good practice and a good idea to embrace that type inference feature, so to not unnecessarily specify the type in addition. You can do that, you can explicitly state the type, but it's really redundant. It just means more work from your side, and therefore you should not do that. You should instead stick to that type inference and use it whenever possible. And that's another super important feature which I wanted to highlight here. Now, type inference is great, and in general, up to this point, we already learned quite a bit about TypeScript and its core types. But up to this point, we also always had the scenario that every variable took just one type. So we always had just one possible type that could be stored in a variable. Just a number, or just a string, or just a Boolean. And often, that is what you need. But sometimes you want to allow multiple different types. Let's say here for the course. We might be fine with storing a string in there, but maybe storing a course ID as a number should also be correct. It really depends on what you're building. It's not unrealistic that we could have a variable where both a string as well as a number should be allowed. Or that you have some variable which should allow two different kinds of objects. And for this scenario, that you have more than one type which you want to allow, you have a feature called union types. A union type is a type definition that allows more than one type. You add it like any other type assignment by adding a colon after the variable name on the left side of the equal sign, and then your type. Now, I mentioned that explicitly setting string again here would be redundant. But it's not redundant if you don't want to use the type inference here, but if you instead want to specify such a union type, hence allowing multiple types. You set up such a union type by adding a pipe symbol after your first type and then adding another type like number. And you can have as many types which you want to allow here as needed. But here I just want to have string or number. And now you see that that error which we had down here before is gone, because now we are allowing a number alternatively to a string value. And of course you can use such a union type anywhere where you have a type assignment, not just when you're using type inference. I could also use a union type up here, allowing username to be a string or let's say an array of strings, for example, so that we have first and last name in an array, for example. That's also something I could allow here. Union types are another key TypeScript feature which allows you to define more flexible values and types.